Good day, doctor. My name is Divya Thomasavam. Today, my group and I we will present a learning of pain-based approach in biology education, where teaching strategies are developed from our observations of students' challenges and learning needs. Based on our group's findings and prior classroom observations by some of us, we identified that many biology lessons are still very highly exam-oriented and also focused on memorizations a lot. As a result, these students, they really struggle to visualize these abstract topics, such as in genetics, ecosystem interactions, and pollutions, especially when, learning remains passive. So these learning pains not only reduce these students' motivation, but also prevent students from developing their critical thinking and problem-solving skills. Therefore, our group, we have come up on selected two active teaching strategies. One will be gallery walk and the other will be scenario-based learning to address these challenges. These strategies, goal is to promote visual exploration, communication, collaboration, and also real-world applications. Our learners mainly focuses on our secondary school biology students with mixed academic abilities and diverse learning styles. While some are, confident and active, others still remain passive and hesitant. Most have basic prior knowledge, but they would still need more student-centered experiences to truly understand and apply these biology concepts meaningfully.
Next, several learning behaviors can be noticed among the students. First, they tend to depend heavily on memorization, especially when learning biology. During class discussion, participation is low and many students prefer to stay quiet rather than share ideas. They also face difficulty visualizing abstract biology concepts, which make it harder for them to understand topics clearly. In addition, there is limited interaction with peers, so collaborative learning is not happening actively. These behaviors show clear learning pains. Some students find abstract topics such as genetics and ecosystem interaction confusing and difficult to imagine. There is also a fear of making mistakes, which reduces confidence and prevents them from asking questions. Because of passive learning habits, motivation and engagement become low. Lastly, students struggle due to a weak connection between theory and real-life application, making biology less meaningful and harder to remember.
In addition, passive learning can lead to low motivation and low engagement too, and there is often a noticeable gap between theoretical knowledge and real-world application. So, to address this challenge, learning should be active, visual, and student-centered. Incorporating movement and collaboration can greatly enhance engagement. Abstract concepts are best taught interactively and in real-life context, while strategies like gallery walk encourage peer learning and active participation. Moreover, scenario-based learning fosters critical thinking and helps students apply concepts in real-world situations. Overall, this approach is not only make meaning more meaningful, but also help bridge the gap between theory and practice, ensuring students can better understand and apply biological concepts.
Hi doctor, today I'm going to explain about an active learning strategy called gallery walk. First, preparation. The teacher prepares several stations around the classrooms. Each station contains materials like students' work, posters or question set. Next is the gallery walk itself. Students move in one small group from one station to another. As they walk, they observe, read and interact with the materials displayed. At each station, students engage in discussions and answering the guiding questions. This encourages critical thinking and peer interaction rather than passive listening. Finally, we have reflection session. Students share their observation, ideas, and what they have learned. This step is very important because reflection helps deeper understanding. The more you reflect, the more you learn. Overall, gallery walk focuses on three main elements. Movement, which keeps students active. Visual learning, which supports the understanding. Low pressure, as students learn collaboratively in group. In conclusion, gallery walk promotes encouragement, collaboration, and meaningful learning in the classroom.
Teacher's role. The teacher prepares learning stations with guiding questions. For example, in a biology topic like human digestive system, each station focuses on one organ such as the mouth, stomach, with questions like what is the function of this organ. The teacher facilitates and guides discussion. For example, if students are confused about enzyme function, the teacher gives hint instead of direct answer to the students. The teacher encourages participation without pressure. So even shy students also feel comfortable when sharing their ideas. Finally, the teacher observes students' understanding and interaction. Next is the students' role. Students move around station in group. They discuss and share ideas actively. Students collaborate with group members by sharing roles such as writing answer, explaining diagram, or asking questions activity. They also ask questions freely. What is the benefit of gallery work in biology? Let's see. Gallery work improves understanding through visual materials. It also builds confidence when students explain their answer at each station. It also encourages active learning because students think, discuss, and analyze instead of memorizing the facts.
Now I'm going to talk about scenario-based learning. Scenario-based learning is a teaching approach where students learn by solving real-life or realistic situations instead of only listening to explanations. The key elements are it uses real-world situations, experience, and reflection, and it encourages active participation. Then it focuses on problem-solving and decision-making. This slide shows a scenario-based learning activity flow using the 5Cs model. It is designed to help students think critically and make meaningful decisions. First is context. The students are given real-life situation to understand the background. Next is challenge. It's a problem introduced to stimulate thinking. Then choices. Students explore different options they can take. After that, consequence. They analyze the possible outcomes of each choice. And the finally is contemplate. Students reflect on the best decisions and what they have learned. So overall, the 5Cs approach encourage active learning, critical thinking, and responsible decision making.
Now is the benefits of scenario-based learning. The first benefit is students are more easier to understand. It's because biology concepts are often abstract and students are difficult to imagine it. So by using real-life scenarios such as nutrition issues, diseases, students can relate what they learn into real-life situation. Next, scenario-based learning method also can reduce learning pressure. It's because by using this learning method, students only focus one problem at a time. They can learn step by step and make the lesson less stressful and more manageable, especially for those weaker students. Not only that, this learning method also can improve student thinking and also problem-solving skill. It's because in this learning method, students are encouraged to analyze the cause and effect of the problem rather than just memorizing the fact. The last benefit is this learning method promotes teamwork. It's because in this learning method, students are encouraged to work in a group to solve problems. So they will share ideas, contribute to their abilities, and also support each other in a group.
Let me introduce a learning scenario based on a real-world problem. In this scenario, a river near the students' community is becoming polluted due to factory waste, household rubbish, and agricultural chemicals. As a result, fish are dying, plants are disappearing, and villagers are getting sick. These situations help students connect what they learn in class to real life. So, student roles is they take on real-world roles to solve the problem. First, some students act as environmental scientists. They identify different types of pollution and study how pollution affects plants, animals, and humans. So, while other students act as community representatives, they consider how pollution impacts villagers' health and livelihoods, and they suggest action the community can take. So in this activity, the teacher acts as a facilitator, not a lecturer. The teacher introduces the scenario and guides students by asking probing questions, such as what will happen if pollution continues and who is most affected in the ecosystem. This approach encourages critical thinking, collaboration, and active learning.
Strategies like gallery work and scenario-based learning help students understand complex genetic concepts by linking them to real-life environmental issues. Overall, these approaches make biology learning more meaningful, engaging, and student-centered.